Landon? Okay. All right. Everybody's good with this so far? All right. These guys get a little bit more involved. This one here, remember that your exponent only belongs to the one next to it. Those are factors. That's one term. Terms are separated by plus and minus. That's one term. They're all factors. So product, you're going to separate into an add. Once you do, you can bring the exponent down in front. Leave log base 6. Your base will stay the same through the whole expression. This one, you have to be careful with this one. Take the radical out, turn it into an exponent, bring it down in front. Now, that belongs to this whole divide. A divide says subtract. So if you just did this, it only belongs to the ln x. It belongs to the whole thing. So either put parentheses around it or distribute the 1/3. Or, before you even start, you can distribute the 1/3. You know, the raised to the power rule. That's your exponent raised to the power rule. It has the same effect with a log. If you would prefer to do it then, that's fine. 61, again, this part was just a qualifier. Because if we put a 1 in here, your domain for your logs is 0 to infinity. So obviously we can't use a 0. If we used a 1, this would become 0. So it's just saying greater than 1. It's just a qualifier. It doesn't affect it when you take it apart. So you undo the divide. This stays right here. That's an argument. You just keep it together right there. And you only bring down this exponent. Now if you wanted to, if you saw a little further, you could separate this into your perfect squares and separate that. Did you have to? No. If you wanted to do with the perfect squares, you can. This one, separate your divide. Now the nice part about this, remember I told you order of operations. Make sure you're following your order of operations. When you separate your multiply into an add, when we go left to right, it's going to do this multiply first. And then it's going to do a divide. The opposite way doesn't work. If it was this, and you had to separate it first, and you did 5 ln z minus 4 ln x plus 1/2 ln y, order of operations would do this first. And in that case, in your denominator, you would have to put parentheses around that. It's the same as a fraction. You have to put your denominator in parentheses. Okay? This one was the big one. Oh, you didn't have this one. Okay. Oh, I told you not to do that one, right? Right. Okay. Okay, we'll flip to these. These are condensing. All right, you tell me if you have any questions. This, by the way, is not a perfect square. So you have to leave it like that. If it was a perfect square, we could separate it, but it's not a perfect square. Whatever the log base it is, we'll keep the same log base. Now they were probably good until the very end here. This one, bring up your exponent. This one was a nice one. You had to go from within the brackets first, just like you would do order of operations. Inner parentheses first. This is an add, so you were multiplying. So you bring this out as a multiply. If you wanted to over here, you could do x squared minus 4. If you saw that they were your perfect square set, your perfect squares. Your conjugate there. Then come out here. Bring this 2 out. This 2 either here or here. Or if you wanted to, x plus 2 squared, x minus 2 squared, if you separated it to the power there, That works also. Last thing, bring out your divide. Put your x over whatever you made your denominator. Either one is fine. The x squared minus 4 probably just looks a little neater, but if you leave it x plus 2x minus 2 squared, just remember to put that in parentheses. You can't just square one factor. You got to square both. If you did this, that works also. Raised to the power. It doesn't look as good, and really that's really probably not the way we should leave it, but it does. I wouldn't leave it this way, but it does work. Questions on any of this? No? You did it, okay. Alright. Today we're going to look at a little bit of graphing today. I want to do some graphing. We're gonna look at some of these, and we're gonna look at some of their domains. Okay, in your calculators, if you have the log base, use it. In your y equal, use your log base. Guys, I need your attention up here. Your 7 goes in here, and your x. If you don't have the log base, you have to use the change of base formula. Log x over log 7. The one below stays below. And you should be able to graph. Your graphs for all your bases look the same. Your sketch looks the same. As the base gets larger, it just gets closer here and closer here. Same thing like the exponential curves. A little bit of a review. The exponential curves, same thing. As the base got larger, it got a little closer to the y-axis. So logs interchange your x and your y. So therefore, as the base gets larger, instead of getting closer to your y-axis, it gets closer to your x-axis because you swap it out. The attributes stay the same. Again, your domain is from 0 to infinity. Your range, all real numbers. Your asymptote is your y-axis this time, and your point, God bless you, is your 1, 0. We swapped them all out, right? These are reflections over the line y equals x for your exponential curves. And as they got bigger, they would hug this tighter. It does the same exact effect for all your bases. So when you have to sketch and do your transformations, I would really, really rather you do a sketch than put it in your calculator. Like if we wanted to take this and do another one with the transformation to it, we should be able to sketch a graph, sketch your basic log, and shift it up 4. Use this point to help you go up 4. And you should be able to give me a sketch, give me your domain, your range, what changes, even without using your calculator. That's really our goal, to be able to do these. You can use your transformations and never really have to pick up your calculator. Okay. This next one is just a little tricky to, whoops, I'm sorry. This next one is just a little tricky to put in your calculator. If you have change, I'll do it again with this one. If you have a change of base here, if you have the change of base formula, this and this work fine. If not, this all goes in the numerator. So it's going to be log x over 3 over log 3. Okay. Same type of format, but we just have to change it to change the base. I want to hit a couple of those homework questions with you so that we do some of the transformations and we do the domain. And you might not really have to use your calculator. It's my goal for you not to. If you need to check on your calculator, absolutely. But what I've been finding is you're just giving me the last statement and putting it in your calculator and giving me that sketch. I really like to see your transformations going through. I need you to have a good understanding of it. So let's take a look at your homework. God bless you. Guys, every time I turn to the board doesn't mean we all have to start talking. Okay. All right, let's skip this one. That one's just a basic log. Let's go to this one. Okay, no calculators. What difference will log base 6 mean when I go to graph a log base 6? No difference. So it's going to look like this. Here's my log base 6. I want you all to start the same way. Domain, range, asymptote, x-intercept. What's the first transformation that's going to occur? A horizontal or a vertical? Horizontal shift left 2. And I need you to use horizontal shift left 2 units. So we're going to take this and we're going to, from 1, 0, it's going to move over 2. So I'm going to be at the -1, 0. What else moved because of that?
So you always have to draw that line for every...
Well, I want you to draw the transformations out. What I find is happening is everybody's just putting this in their calculator, giving me the last sketch. But I need you to see the transformations. If you just cut to the chase, you don't really see them.
I mean not the dollar one. It's always gonna be like that.
Well, all your logs will look just like this. All your white log 6 base, log 10 base, they just get a little bit closer to the axis as the larger number. But for a sketch, they should all look like this. Now, we translated this. This guy also moved over. It moved over 2. We are now here at x is equal to -2. What else did this change? The reflection? Well, we didn't get to reflection yet. What else did it change? Domain. Your domain changed right now from -2 to infinity. Right? So far. And we know your asymptote changed to -2. A horizontal movement will change your domain, will change your asymptote. Your range, no effect. Okay, next. You guys just said reflection where? X-axis. Because this is not next to the X, it's next to the Y. So Y is going from positive to negative. I'm going to take this and reflect it. I'm just going to reflect that. Did it change my domain? No. Did it change my range? Nope. Did it change my asymptote? No. So I still know my range. I still know my domain. And my y-intercept, I can find my y-intercept, but let's find your x-intercept. Your x-intercept says y has to be 0. So we plug in a 0. Flip it around if it's helpful. Oops. Actually, can you spot your x-intercept too on this graph so that we can check it with your x-intercept? Okay. We've got 6 to the 0. What is 6 to the 0? 1. God bless you. You're going to subtract. Oops. What did I do wrong? 2. Oh wait, we never put the x-intercept over here. Sorry, I never put it down.
Isn't it negatives instead?
Yeah, this just has a reflection in this, but even if you put a negative here, anything to the 0 power is 1. So subtract 2, I just never put it down. I was looking for it and I'm like, where did I put it? So subtract 2. and x is equal to -1, which we said we would find. I need you to know algebraically how to do this. This one, yeah, we can tell on the graph, but I need you to do it algebraically as well. Another way to find your domain, if you struggle with your domain, is to use this concept. Your domain for your logs has to be greater than 0. So another easy way to do this is this guy has an effect on your domain. It's a horizontal shift. So set this greater than 0 because your original domain said x was greater than 0. So this is another way to find your domain. If you struggle with seeing the transformation, algebraically, you could solve it like this. So x has to be greater than -2. And isn't that my domain? -2 to infinity. Okay, so if you have a hard time seeing a domain, take whatever horizontal movement is there and make it greater than 0. Because your domain has to be greater than 0. We can't take the log of 0. We can't take the log of a negative number. Make sense? All right, let's try another one together. This is your homework, so if we get through a couple of these, this would be nice. All right, let's do this one. Start with your basic log. Log base 5. Not a lot of difference in log base 6. A little closer. The 6 is a little closer to the x-axis, but they all work the same. Domain. Range. Asymptote. And x-intercept. All right. What's the first transformation we're going to do? Good. A horizontal shift right 1. So we're going to use this point. We're not going to use our calculators. And we're going to move this over 1 to the 2, 0. And just kind of make a sketch that goes like that. Did we change the domain? What else did we change? Asymptote. So now my domain moved over 1. So my new domain so far is 1 to infinity. And my asymptote moved over 1. It was x equals 0, and now I'm x equals 1. And your intercept so far has moved over. Good. That's what this horizontal shift caused. And we're going to say this is a horizontal shift, right? 1 unit. Okay, what's the next transformation that we see? Vertical shift up 4. Good. Nope, the range doesn't change. Good. So we're going to take this guy and move this up 4. So at the 2, 4, we know we're passing through here. Did we change our domain? At the vertical? Nope. And as Rich said, we did not change our range either because our range was always all real numbers. So the range is still all real numbers. The domain stayed the same. The x-intercept is going to change. And we're going to have to work with this one. But our asymptote stays the same. So all we have left to do now is find your intercept. Also, to find your domain, if this is troublesome, take the horizontal shift, whatever argument is in here, set it greater than 0. Because that's what your domain starts out as, greater than 0. So x is greater than 1. Isn't that our domain? Yep, so we can find that algebraically as well. You can do this without your calculator. So x-intercept. Let y equal to 0. Does this have a y-intercept? Nope, because it can't go that far back. We've got an asymptote blocking it. So 0 equals the log base 5 of x minus 1 plus 4. If it helps, if it's easier to look at it the other way around. Okay, this is just as easy to swap it around. Okay, move the 4 to the other side. If I make a mistake, it doesn't let me correct it real easily. Okay, so we've got 5. If you have trouble flipping this, again, don't forget log equals exponent. This will help you flip it. 5 to the negative 4 equals x minus 1. You're going to add 1, so 1 plus 5 to the negative 4. This causes a fraction, a reciprocal, not a negative. 1 over 5 to the 4th, which is a very small number, plus 1. So if you put it in your calculator, you will find that it's slightly bigger than 1. Slightly larger than 1. A little tiny bit larger than 1. Okay? If you just put that part in your calculator. And we can see, it was at the 1, 0, look how close we are to that 1. Even just with our sketch. Yes?
What does that say?
Log equals exponent. My right side of my board never works that well. Okay? Alright, so you guys can complete the rest, okay? And this is what I'm looking for on this homework. I'm looking for each chart. Okay, I did 2. How many left do you have? 6. Okay. I'll tell you what.